My name is Lawrence Rosenberg, and this is the Alpha Human Podcast. On today's show, we're going to pick up where we left off on the last episode and get back into what your doctor is not telling you about your cancer. God forbid you have it. First, let me say up front that I am not a doctor, nor am I a medical or healthcare professional. And the content of this podcast and any information, advice, opinions, or statements within it are not intended and are not to be used as a substitute for professional medical advice. For diagnosis or treatment, you should not disregard or delay in obtaining medical advice for any medical condition you may have, and you should seek the assistance of a healthcare professional for any such conditions, and always inform your doctor of any changes you may make to your lifestyle and discuss these with your doctor. Okay. So in the last episode, I talked about having been diagnosed with kidney cancer almost 7 years ago when the doctors found a grapefruit-sized 14-centimeter tumor on my left kidney, as well as a smaller 2-centimeter tumor in the center of the right kidney. I had the left kidney and tumor removed, and my strategy for the right kidney was to do what I could from a dietary and lifestyle perspective to mitigate its progression, coupled with monitoring the tumor closely and to only have some type of intervention if the tumor got to the point where I had no choice but to deal with it, given that if the intervention went wrong and damaged the right kidney beyond repair, then I would end up on dialysis, and that's the last thing I want. With that said, it's important to note that my decisions in dealing with cancer have been weighted against quality of life, with quality of life always being my North Star. And so far, God bless, I've lived the last 7 years feeling amazing. I am super disciplined. I'm committed to diet, right? A particular approach to nutrition, which keeps me feeling strong and robust. That's a carnivore diet, by the way. I lift and exercise every single day. And over time, I have added prayer and gratitude, breathing exercises, and contemplation practices to my lifestyle. And other than having to recover from my 2 surgeries, I've had a phenomenal quality of life. Now, by the way, that second surgery was very recent because they found that the kidney tumor, although it's been stable in my right kidney, that moved to the liver, right? So they found a 2-centimeter tumor in my liver. We had that removed in August. Everything else looked good. And I've been rocking and rolling since. Now, again, since originally being diagnosed with kidney cancer, I've sought out the advice of and worked closely with probably 10 doctors, a mix of surgeons, interventional radiologists, and an oncologist. And I've done an enormous amount of research on my condition to empower myself. Being diagnosed with cancer can be a complete and utter mindfuck, especially when you hear it from the doctor for the first time. And the thought of your mortality when you hear this kind of thing will hit you in waves at various and unlikely times after you learn of your predicament. And I'll tell you what, if you're not careful, it can spin you into a terrible place psychologically. However, what saved me from hurtling down a rabbit hole of fear and depression was that the day after I was diagnosed, I decided that instead of focusing on the fear and sorrow of it all and the horrible questions you inevitably contemplate when faced with possibly dying sooner than you thought you might, I decided to research and study. And this is really what kind of saved me mentally. I went online the very next day after I was told 7 years ago that I had this massive tumor, which was the size of a grapefruit, right, on my left kidney. The very next day, after spinning out the whole day and night before into some dark, dark places. But the very next day, I typed into Google how to defeat cancer. And from that point, my journey has led me down a path of discovery that has strengthened and motivated me and continues to do so after all these years. And hopefully I can inspire some of that in anyone else out there listening to this who might be faced with a cancer diagnosis. So, and by the way, this is at the heart of my message, which is if you have been told that you have an illness or a life-threatening condition, especially a life-threatening condition like cancer, if you've been diagnosed with something like this, do not abdicate your responsibility to be the most significant player in the treatment side of the equation. Take the leadership role in your journey towards surviving, towards healing, towards recovering. Now, your doctor is an important part of the team, right? Your team, but like any player, the one you have chosen may not be the best person for the job initially, right? You make this initial decision, you're seeing this doctor, hey, they might be the best person for that particular role on your team, but it may turn out they're not. And by the way, they certainly don't know everything, and they might not be the all-knowing expert you assume they are, which is why you need to get second opinions and even third opinions, which I have. And you have to research everything they tell you. Research all possible strategies. The more knowledge you gain, the more you uncover, the more self-assured, more enlightened you will become. Do not let fear force you to stick your head in the sand and blindly leave everything in the hands of your doctor, because you're just one of their many patients and one of their multitude of responsibilities, and they are only human. As good as even the best doctors are, and chances are you're not seeing the best of the best, as the true geniuses, like in any endeavor, make up just maybe 0.1% of the entire field. So the majority of oncologists are stressed out, they're frustrated, and they're often depressed. And we'll talk about that, right? Not in this episode, but on the next one. Nevertheless, for oncologists, it's an emotionally draining job, right? And so suffice it to say, they're fallible, right? They're only human, they make mistakes, and they are also hemmed in by standards of care that might not always work in your favor, especially when it comes to all the possible strategies that might be available to deal with your particular cancer. Now, with that said, seek out the best doctors, right? Seek them out. I have a very particular method for doing this, which I will teach in an upcoming podcast, but question the doctors you have chosen. Don't simply accept everything they say. Inform yourself of all the variables by doing independent research and ask them questions. Many people regard doctors as some type of demigod or holy figure that you should never question, and most people blindly follow the doctor's orders. If you don't understand something that a doctor tells you, question it. If something doesn't seem right to you, right? If you feel it in your gut that maybe something isn't quite right with what they're saying, question it. Do not be afraid to speak up, and do not view the doctor as an almighty being or as your savior. The only one who can save you is you. And no one will care more about your predicament than you will. So when seeing a doctor, view them as they should be viewed, as a potential member of your team who you are hiring for a job. The most important one of your life, actually, right? So ask questions because you are interviewing them for the role of a lifetime. And you are assembling a team with the goal of being victorious. And it is up to you to ensure you have built a team that is prepared to do battle and to win. You are the leader of this team, and your most important weapon, your most crucial tool, is knowledge. So learn how to strengthen your mind for the fight. Learn how to strengthen your body for the fight. And with your research into doctors, into your illness, and into possible strategies, you will be able to decide on the best solution for you. Do not leave this in someone else's hands, even if their title is doctor. Question everything, because information is power. And this has never been more true than when your life depends on it. Okay, so I'll stop preaching for a moment. On the last episode of the podcast, we closed out by talking about how I recently found out I had a new tumor, right? The one in my liver. I had a successful surgery to remove it in August, and the pathology report confirmed that it was the same type of cancer as the one in my kidney, which is known as chromophobe renal cell carcinoma. And given it had popped up again, this time somewhere other than my kidney, and by the way, this is known as a metastasis, I decided now was the time to start contemplating possible drug strategies, as heretofore I've had no interest in taking cancer drugs. and have only used surgical interventions as my medical strategy over the past 7 years. Nevertheless, given a tumor had now shown up in my liver, I figured it would be advantageous to not only know the genetic background of my cancer, but also to explore what targeted therapies might be available just in case. Always good to know what possible tools might be useful should I ever want to explore that route. So after surgery, we had the tumor sent in for genetic testing to uncover what particular mutations might be afoot. And I made an appointment with an oncologist to discuss possible drug strategies. If not for now, then for the future, just in case this cancer pops up again and surgery turns out not to be an easy option like it's been the last 2 times. Not that surgery is easy, but certainly, to me at least, it's preferable than giving yourself all kinds of drugs and side effects that come with that. Okay. So in my genetic sequencing report, they did an analysis of 183 genes, and they identified a number of mutations, right? They identified the following variants of what they refer to as uncertain significance. Now, a variant is an alteration in the sequence of DNA that makes up a particular gene, otherwise known as a mutation. And uncertain significance means there's not enough information about the mutation to know whether it increases your risk of developing a disease such as cancer. However, in my case, we already know that I have cancer, so let's look at what they found. Because no matter what the uncertain significance level is, we know in my case that there is serious significance to any mutations they identified. So let's look. Because they found three particular issues. Number one, this report found what is called an in-frame insertion in the axin 1 gene. So that's AXIN1, axin 1. And what they found was there was a variant allele fraction, or VAF for short, of 42%. So I'll explain what a variant allele fraction is in a moment, but an insertion is a type of mutation that changes the DNA sequence by adding one or more nucleotides to a gene. And as a result, the protein made from the gene may not function properly. And mutations in the axin 1 gene have been associated with liver cancer, which I do not have, even though I had a tumor in the liver. It was not a hepatocellular cancer, right? A liver cancer. It was chromophobe kidney cancer that had moved to my liver. So this mutation, axin 1, has also been found in certain types of ovarian cancer and certain types of brain cancers. So all in all, this is where the term uncertain significance really comes into play, right? Again, uncertain significance means just because you have the mutation, it doesn't mean you will get the disease. And although I have an axin 1 mutation, it has not developed into a disease that I'm dealing with. Okay, so let's move that aside. The second finding was a my-sense variant. That's what they call this, a my-sense variant in the DDX41 gene for a variant allele fraction, or again, VAF for short, of 29%. Now, a my-sense variant is a mutation in which the genetic code is altered in a way that produces an amino acid that is different from the usual amino acid at that position. And this amino acid change may alter the function of the protein produced by the gene. And we're going to get into how genes and proteins and amino acids work and what roles they play in cancer shortly. But for now, let me explain again what VAF means. VAF is used to infer what an alteration in the genetic code, VAF is used to infer whether an alteration in the genetic code is what is known as a germline mutation. So germline cells are the cells that form eggs in females and sperm in males, and they contain the genetic information that is passed down from one generation to the next. So if your cancer has this type of mutation, then it was inherited from your parents. And so the variant allele fraction gives us an indication of whether the alteration is an inherited mutation or whether the variant comes from somatic cells, which are any cells other than the reproductive cells. So somatic cell alterations are the most common mutations found in cancer. And these are mutations that result after you're conceived and are the result of damage to your genes due to environmental factors, such as exposure to, say, radiation or chemical toxins. Now, a variant is potentially a germline mutation and inherited from your parents if the VAF, again, variant allele fraction, is approximately 50% or 100%. So this is really important to learn in my instance because chromophobe kidney cancer is very rare. Only about 5% of renal cell carcinomas are chromophobe tumors, and they're associated with a genetic disorder known as Birt-Hogg-Dubé syndrome, or BHD syndrome, which is characterized by bilateral multifocal renal tumors, which, by the way, I have. Bilateral means in both kidneys. And in BHD, they find a germline mutation in the folliculin gene, aka the FCLN gene, which means I may have inherited this cancerous mutation. So that's something else I needed to find out. And so I recently had additional genetic testing to identify whether or not I have this FCLN mutation. And the good news, guys and gals, is that I do not. And that is a relief, because even though I have this cancer, knowing that it's not an inherited cancer means my kids don't have to worry about it. So that's a big weight off my shoulders. But now back to this DDX41 mutation, because this is where things get really interesting. In a paper entitled DDX41 Regulates the Expression and Alternative Splicing of Genes Involved in Tumor Genesis and Immune Response, they discuss a study that found DDX41 downregulated the expression levels of oncogenes, including LCN2, TP63, MYB, CDK5R2, and the KIT gene. And when I say KIT, that is spelled KIT. So let's look at that statement. Let's pull it apart. Let's unpack it. First off, an oncogene is a gene that, if mutated, has the potential to cause cancer, and downregulate means to suppress. So what they're saying here is that if the DDX41 gene is functioning normally, then the DDX41 protein it generates will suppress certain oncogenes like KIT from making too much of the protein that codes for uncontrollable cell growth and tumors when their expression is upregulated, right? So downregulated means suppressed, upregulated means the chains have been pulled off and the pedal is to the metal, right? However, this report, my genetic testing analysis shows that in my tumor, they found the DDX41 gene to be mutated. Now, why is this relevant to me? Well, guess what else they found? The third and last finding of my genetics analysis identified that I have a copy number gain of the KIT gene. So copy number alterations, whether that is a gene amplification, otherwise known as copy number gain, or a gene deletion, which is a copy number loss, are somatic changes to chromosome structure that result in gain or loss in copies of sections of DNA. Copy number alterations are common in cancer cells and contribute to cancer cell growth, drug sensitivity, and drug resistance. So I have a mutation of the KIT gene, also known as c-KIT. C, right, the letter C, and a little little hyphen, and then the letters KIT. And the oncogene KIT was one of the genes whose expression was upregulated specifically in chromophobe cancers, according to a paper entitled Overexpression of KIT in Chromophobe Renal Cell Carcinoma. So I not only have a mutation in a gene directly associated with my type of cancer, the KIT gene, I have a mutation in the tumor suppressor gene, DDX41, that would typically restrain the KIT gene from activating uncontrolled cell division, i.e. tumor genesis in cancer. So what does the KIT gene actually do besides play a role in kidney cancer? Well, the KIT gene provides instructions for making a member of a protein family called receptor tyrosine kinases. Tyrosine kinases belong to a larger class of enzymes known as protein kinases. Now, before I get into what these kinases do, it's important to understand some basics about genes and about proteins. I want you to think of a cell as a factory. And this factory has walls, better known as lipid membranes. And by the way, lipids are actually fats. Now, this cellular factory also uses fuel. And this fuel is made up of glucose and, by the way, fats as well. So glucose and fats can act as fuel. And the factory also has a manual or a set of instructions known as DNA, which is used to carry out the tasks of the factory. Now, each instruction in that manual is a gene that is responsible for producing a machine that carries out a very specific task. And that machine is known as a protein. How do these machines, or should we say proteins, work? Well, proteins are made up of building blocks called amino acids, of which there are 20, including glutamine, cysteine, right? You may have heard of those. Yeah, in fact, you'll actually hear a lot more about these two amino acids again later on in these podcasts that I'm doing about cancer, especially my cancer. And by the way, tyrosine, and speaking of tyrosine kinases, tyrosine is another one of those 20 amino acids. Now, each amino acid has different properties, and they can be strung together in a multitude of combinations to make many different proteins that all have unique functions. I believe there are about 25,000 different protein combinations that can be made in the human body. And examples of these include hemoglobin, which is a protein whose main function is to transport oxygen from the lungs to different tissues in the body. We also have proteins known as actin and myosin, which are the proteins responsible for muscle contraction. Some proteins function as chemical signaling molecules that you know as hormones that act to control or regulate specific physiological processes, which include growth and development and metabolism and reproduction. And by the way, enzymes are also proteins. What enzymes do is they help speed up chemical reactions in our body, such as digestion or liver function. And a kinase is an enzyme. And protein kinases are enzymes that modify other proteins by adding phosphates to them. You also have lipid kinases and glucose kinases, which transfer phosphates to fats and sugars. Now, back to building these proteins for a moment. When a gene is constructing a protein out of these amino acids, there's some amino acid residue which forms. And it's important to note this because what protein kinases do is they transfer a phosphate group from a high energy phosphate donating molecule called adenosine triphosphate, ATP for short, to one of 3 amino acids within the cellular factory. Now, most protein kinases act on the amino acids serine and threonine. However, tyrosine kinases transfer phosphates to the tyrosine residues of specific proteins inside the cell. And by the way, we'll talk more about what ATP is later on, but this process of transferring phosphates is known as phosphorylation. Now, phosphorylation is a crucial mechanism for communicating signals within a cell. And that communication is known as signal transduction. And it regulates cellular activity such as cell growth, cell migration, cell differentiation, which is something we'll get into later on as well. And it also regulates what's known as apoptosis. Apoptosis is a cell suicide program, otherwise known as programmed cell death, that organisms use to eliminate unneeded or potentially dangerous cells like virus-infected cells or precancerous cells. Unfortunately, some dangerous cells escape the clutches of cell suicide and become full-blown cancers. Now, just about 1 in every 40 human genes codes for a protein kinase. And there are 90 unique genes that produce tyrosine-specific kinases, such as the KIT gene. And if a kinase gene, sorry, I'm stumbling over my words here, but if a kinase gene like KIT develops a mutation, then the kinase proteins they produce can become dysfunctional and can lead to a dysregulated series of signals, potentially resulting in a malignant tumor. Essentially, these protein kinases can become stuck in the on position and cause unregulated growth of the cell, which is a necessary step for the development of cancer. Therefore, blocking these initial signals via drugs known as tyrosine kinase inhibitors, TKIs for short, can prevent the abnormal action of the mutated or dysfunctional tyrosine kinases. So let's dive deeper on tyrosine kinase inhibitors and how they work. They're pretty interesting drugs because TKIs block very specific TKIs block specific tyrosine phosphorylation activation of a panel of cell surface angiogenic growth receptors. Cell surface receptors are receptor proteins coded by specific genes that are embedded in the plasma membrane of cells. As we mentioned earlier, cell membranes are the walls of our cells. And these protein receptors that are embedded in those walls receive signals and bind to extracellular molecules or signaling proteins known as ligands. And those ligands are coded by other genes that allow them to change the activity of a cell. So tyrosine kinase inhibitors thus have the capacity to moderate new blood vessel formation. So the growth factor receptors affected by tyrosine kinase inhibitors are vascular endothelial growth factor receptor, otherwise known as VEGFR, basic fibroblast growth factor, known as BFGFR, platelet-derived growth factor receptor, also known as PDGFR, and epidermal growth factor receptor, or EGFR for short, according to the book Anti-Angiogenesis Strategies in Cancer Therapies. So as an example, when we talk about these vascular endothelial growth receptors, right? Or these vascular endothelial growth factors. An example of this is a signaling protein produced by the VEGF-A gene is the VEGF-A protein. And the VEGF-A protein binds to a very specific receptor protein on vascular endothelial cells known as VEGF receptor 1 or VEGF receptor 1 and VEGF receptor 2 or VEGF receptor 2, right? So those two receptors stimulate the formation of new blood vessels, otherwise known as angiogenesis. And what is angiogenesis? Angiogenesis is the formation of new blood vessels from existing vasculature. And it is a major factor in the development and growth of lots of different cancers. In fact, according to a paper entitled Unraveling the Role of Angiogenesis in Cancer Ecosystems, and I'll quote, "In the absence of new vasculature, tumor growth is normally limited to no more than 1 to 2 millimeters, right, which is really small. And these small tumors obtain nutrients and oxygen from nearby blood vessels, where angiogenic processes are not observed. And these what are known as avascular tumors, right? So they're not very vascular, reach a very stable state characterized by a balance between proliferation and apoptosis, right? So there's a very delicate balance there between them starting to proliferate and to actually die off. Now, to grow beyond the restricted size of 1 to 2 millimeters and sustain unlimited proliferation or growth, tumors require their vascular network to be extended. And this transition from avascular or an avascular state to the angiogenic phase is commonly known as an angiogenic switch. And this switch occurs early during tumor progression. And so TKIs, right, tyrosine kinase inhibitor drugs, also called anti-angiogenics, they block blood vessel growth. And by blocking nutrients and oxygen to a tumor, these angiogenesis inhibitors can starve the cancer cells. So with this in mind, it was no surprise that my surgeon, who I researched heavily before setting an appointment, and who is one of the top surgeons in the country that deal with liver tumors, went on to tell me that one of my options, instead of surgery, was to undergo a regimen of tyrosine kinase inhibitors. And that if I chose this option, I could keep the tumor in check for about a year or maybe a year and a half, he estimated. But he also told me that eventually the cancer would develop a resistance to this type of therapy. Very interesting, right? So in his opinion, I'd ultimately need the surgery in order to deal with the tumor. So I started researching TKI resistance or tyrosine kinase inhibitor resistance. And what we find is that the propensity for cancer cells to develop an increased tolerance for these drugs over time turns out to be a major issue in the efficacy of these drugs, of these what's known as targeted therapies. So quoting from a paper entitled BCR-ABL Independent Mechanisms of Resistance in Chronic Myeloid Leukemia, I'm going to quote, although TKIs have dramatically changed the treatment of chronic myeloid leukemia by inducing long-term overall survival rates higher than 90%, which is pretty amazing, approximately 1/4 of patients that have chronic myeloid leukemia develop TKI resistance at some point during therapy. So that's a big number, 25%. I mean, great for the 75% that don't. I mean, that's huge, right? So it's a very powerful drug, but 25% of those patients develop resistance. Now, in non-small cell lung cancer, we also find that most patients inevitably also develop. Most patients, right? Not 25%. Most patients inevitably develop acquired resistance after 9 to 13 months of treatment with the first and second generation EGFR tyrosine kinase inhibitors. Remember, EGFR is one of the angiogenic growth factor receptors. And patients with EGFR activating mutations administered certain third-gen TKIs as a first-line treatment have also been found to inevitably develop resistance after, well, a fair bit longer, but still 18.9 months on average, according to a paper entitled Mechanisms and Management of Third-Generation EGFR Tyrosine Kinase Inhibitor Resistance in Advanced Non-Small Cell Lung Cancer. Hopefully, guys, I'm not boring you with all of this, biotechnical terminology, but it's important that we really kind of explore this in an accurate way. And so please bear with me as I kind of talk through some of the technical terms, and wherever possible, I will try to explain what some of these biotechnical terms mean. All right, so what about tyrosine kinase inhibitors in kidney cancer? Well, according to a paper entitled Determinants of Resistance to VEGF, again, that's the VEGF gene, VEGF proteins, VEGF for short, Determinants of resistance to VEGF, tyrosine kinase inhibitors, and immune checkpoint inhibitors in metastatic renal cell carcinoma. Despite its early promising results in decreasing or delaying the progression of kidney cancer in patients, VEGF TKIs have provided modest benefits in terms of disease-free progression, as 70% of the patients who initially respond to the treatment later develop drug resistance, with 30% of the patients innately resistant, right? Just literally walking into the drug therapy, they're already resistant. They don't acquire it over time, right? They innately are resistant to these VEGF, or again, VEGF tyrosine kinase inhibitors. So irrespective of the percentage of patients that develop resistance to TKIs to varying degrees in different cancers, and at bare minimum, they are exerting some benefits to increase survival rates, and I would argue with far less toxic effects than chemotherapy and radiation. Unfortunately, these drugs are sometimes given in combination with far more harsh cytotoxic chemotherapeutic drugs in an effort to decrease the likelihood that resistant cancer cells will develop. But that's a whole nother issue. Nevertheless, keeping the positive and less toxic benefits of the more targeted drug therapies in mind, and tyrosine kinase inhibitors in particular, I got an appointment with one of the top kidney cancer oncologists in the field, and we set up a 45-minute session in which I was looking forward to diving into my genetic testing results and the possible drug strategies related to the KIT gene finding. And so after going through the preliminaries with the doctor's nurse and then the doctor's intern, the oncologist finally comes in and, after some small talk, goes on to pretty much dismiss the findings in my genetics analysis. I mean, we talked about it for maybe a minute or maybe 2 minutes. And although the doctor acknowledged the finding of the KIT mutation, they said the bottom line is that there are zero targeted drugs or immunotherapies for chromophobe kidney cancer. And that tyrosine kinase inhibitors, which are used somewhat effectively in treating advanced clear cell renal cell carcinomas, which make up the majority, by the way, of all kidney cancers, that even though they're used somewhat effectively in treating those cancers of the kidney, they are not effective, according to my oncologist, in chromophobe kidney cancer, which again is the type of kidney cancer that I have. And that all of the research money is going into these VEGF tyrosine kinase inhibitors. The assumption there, by the way, being, without my doctor actually saying it was, right, because the doctor didn't really explain too much of this to me. I found most of this out on my own and through my own research. But she ended up just making a kind of like a side note during my conversation, that all of the research money is going into these VEGF tyrosine kinase inhibitors. So the assumption there being that they don't see the VEGF mutation or VEGF expression, I should say, in chromophobe kidney cancer. And that in summation, my oncologist really just presented that surgery and ablation, which is where they kind of burn out or freeze the tumor, is my best strategy in dealing with this particular type of cancer, as there are no effective medications. Now, by the way, I should say that as far as strategies go, I agree wholeheartedly, and that has been my approach from day one. I mean, if there's any way to avoid pharmaceuticals, then I'm going to do that. And I absolutely will not do any chemotherapy or radiation. With that said, it should also be noted that chemotherapy and radiation are not typically used in kidney cancer, as kidney cancer cells do not usually respond to cytotoxic chemotherapy. The cells are usually resistant, so they are not a standard form of treatment for kidney cancer, right? However, even knowing this, doctors still use it in some cases, especially the platinum-based chemotherapies, which have been shown to actually cause acute kidney injury and kidney failure. So think of the insanity of that proposition. I mean, you're taking this cellular poison to deal with your cancer. It's not targeted at just the cancer cells, right? It's like a nuclear bomb, killing indiscriminately, as it is highly toxic. Chemotherapy is highly toxic to all cells, with the hope that, okay, it kills enough of the cancer cells and leaves enough of your healthy cells intact such that you survive, maybe for a bit longer, right? But in the process, you end up destroying the organ you're trying to save, right? You end up destroying the kidney. So that's a horrible equation to have to contemplate, and far worse to have to deal with. And my heart goes out to anyone undergoing this type of treatment, this type of chemotherapy. But irrespective of this dilemma, kidney cancer is typically treated differently. Typically, it's treated with systemic targeted therapies and immune checkpoint inhibitors. What's the difference? Well, targeted approaches aim to inhibit molecular pathways that are critical to tumor growth and maintenance, whereas immunotherapy endeavors to stimulate a host of responses that effectuates long-lived tumor destruction. And that's according to a paper entitled Combining Immunotherapy and Targeted Therapies in Cancer Treatment. So they usually like to combine the two if they can. And by the way, these drugs can also cause serious side effects. So these things aren't side effect free by any stretch. But what they don't do is kill all cells like chemotherapy. In cases where targeted therapies actually work, they specifically destroy the cancer cells. And in the case of kidney cancer, when we talk about targeted therapy, as we mentioned before, this typically means tyrosine kinase inhibitors, as well as some what is known as mTOR, mTOR, and HIF inhibitors. Now, I won't get into the mTOR inhibitors or what mTOR is during this series of episodes, but we'll definitely get into HIF and what that's all about in another episode, because it is important to really dive into that one. But nevertheless, according to my oncologist, who is one of the very top doctors in the field of kidney cancer, tyrosine kinase inhibitors and these other inhibitors and immunotherapies do not work in chromophobe kidney cancer. So as soon as my, I wasn't necessarily, prepared to hear that, right? So imagine you go to the oncologist, you go to the doctor, you've just been through these, the surgery, and you want to hear what your drug strategy is for dealing with this, and they tell you there is none. I mean, that's not an easy thing to deal with. So as soon as my visit with the doctor ended, I found myself thinking, is that correct? Right? Is what the doctor's saying correct? That there's no strategies, no drug strategies for dealing with this. Stick to surgery, right? I mean, but what happens in cases where a tumor presents too much risk for surgery? Then what? Are there really no targeted drug strategies? I mean, I don't know. Why would I even ask that question, right? My oncologist is an expert, a top specialist in the field of kidney cancer with decades spent treating renal cancer with drugs. I mean, if anyone knows, my oncologist would know. Oncologists as a whole, they're the experts in using drug therapies to treat cancer. So why would I question any of that? The reality is that I learned a long time ago not to accept anything from anyone, not accept it whole cloth, don't accept it wholesale without investigating it myself. But who am I? What can I investigate? I'm not a doctor. I'm not a scientist. I'm not a medical research professional. So what do I know? Yet, what I ended up uncovering with equal parts curiosity, dedication, and in-depth investigation into medical studies and scientific papers, all available online and easily searched and accessible to anyone who wishes to really look for it, helped me understand my condition far better than any specialist or doctor has ever explained to me, and also led me to discover that there are indeed options to keep in mind. Targeted drug therapies that I can keep in my back pocket should I ever want to try them in the future, irrespective of what my oncologist initially told me during our brief appointment. So the first finding I want to share with you, and we won't get into all of them here. We'll do that in a few other podcasts, but the first finding from my research that I want to share is we already know that the KIT gene was identified in my tumor sample as being mutated. But beyond this, it's also important to note that in my surgical pathology report, which included the results of the immunohistochemical testing the doctors conducted on my liver tumor prior to sending a sample out for genetic analysis, they found that c-KIT, the kinase receptor protein that the KIT gene codes for, was expressed in my tumor as well. And expressed means that a specific protein is being produced at higher levels in the tumor cells than they are in normal cells. However, the result was identified as what is known as patchy weak. By the way, pathologists do immunohistochemical testing immediately after surgery, and it's the proteins being expressed in the cancerous tissue that allows them to differentiate between different tumor types and determine what type of cancer you have. Now, the patchy weak staining pattern in my tumor suggests that not all tumor cells are expressing the c-KIT protein at high levels, and that the expression was not consistently strong throughout the entire tissue sample. Now, this could be due to differences in the distribution of the protein within the tumor, or differences in the accessibility of the protein to the antibodies used in the analysis. A weak or patchy staining pattern may also indicate that the protein is not playing a significant role in the development or progression of the tumor, whereas in other cases, it may be indicative of a potential target for therapy. And although c-KIT expression is found in the majority of chromophobe cases, including mine, the major point to make here is that these tumors do not typically harbor the usual KIT activating mutation. In fact, according to the results of a study reported in a paper entitled c-KIT Overexpression is Not Associated with KIT Gene Mutations in Chromophobe Kidney Cancer, they found c-KIT expressed in 78% of chromophobe tumors that they studied. However, in no cases were the tumors found to have the KIT mutation. This lack of mutation in the KIT gene, unlike what they find in other types of renal cell cancers, may be why targeted therapies like tyrosine kinase inhibitors are typically ineffective with chromophobe cancer. However, I not only have the c-KIT expression, albeit patchy weak, I also have the KIT mutation, which they typically never find, right? They find the c-KIT protein expression, but they don't find the KIT mutation in chromophobe cancer. But they did in my case. So perhaps that makes a very significant difference when it comes to TKIs working. But did my oncologist mention this? Did they mention that very rare difference in my chromophobe tumor that, hey, you've got the c-KIT expression and you also have the KIT mutation, which they almost never find? But my oncologist never mentioned this, not at all. And as mentioned in the previous episode of this podcast, my doctor spent maybe 2 minutes on the subject of TKIs and how they don't work in chromophobe cancer. Okay, so that's a big finding right there that I would have never known about had I not decided to really study my own particular situation, which is why I implore you to study your situation. Okay, the second finding I want to make note of is this. So there's a scientific paper that was published a few years ago in 2019 entitled Exceptional Response of metastatic chromophobe renal cell carcinoma to vascular endothelial growth factor, VEGF, right? Again, VEGF inhibitors. So let me read that again. The title of the study is Exceptional Response of Metastatic Chromophobe Renal Cell Carcinoma to VEGF Inhibitors. Really? That's interesting because I thought that chromophobe cancer doesn't respond to VEGF TKI inhibitors. But this paper, again, the subheadline of this paper is, should increased VEGF-C expression be used to guide treatment? So let's have a look at this, okay? I'm going to read the relevant insights directly from the paper. Quote, there is sparse literature demonstrating effective treatments for metastatic chromophobe renal cell carcinoma, which is what I have. And that statement, by the way, echoes what my oncologist told me, right? No effective treatments for chromophobe kidney cancer. But let's continue. We report a patient diagnosed with chromophobe kidney cancer bearing increased expression of VEGF-C and VEGF-B who exhibited a prolonged response to sunitinib, right? That's a VEGF TKI inhibitor, sunitinib, and has been stable on anti-VEGF therapies for nearly 9 years. What? 9 years. Okay. The tyrosine kinase inhibitor, sunitinib, selectively inhibits the VEGF pathway, and it is a standard of care for metastatic clear cell renal cancer. Although data supporting its use in chromophobe kidney cancer is much more limited, according to the paper. I'll continue. Quote, a 56-year-old underwent palliative nephrectomy. That means they removed the kidney of this 56-year-old who had locally advanced chromophobe kidney cancer with sarcomatoid differentiation. Tumor gene expression profiling, right? I had tumor gene expression profile. No, sorry, I didn't have that actually, right? I had tumor gene mutation analysis, but not the gene expression, right? Or the protein expression profiling. Why didn't I have that? That's interesting. Why did my oncologist order that? Nevertheless, we'll get into that. But tumor gene expression profiling demonstrated significantly elevated VEGF-C expression compared to normal renal tissue and other types of chromophobe kidney cancers. Adjuvant sunitinib was used to treat his residual unresectable lymph nodes where the cancer had metastasized to. The patient demonstrated an exceptional response and underwent complete surgical resection 4 months later. So that means he had that some of those lymph nodes removed 4 months after having the exceptional response to the initial TKI, the initial tyrosine kinase inhibitor. The paper then goes on to say he has been managed with TKIs for nearly 9 years with only minimal disease progression. Fantastic. Wonderful response. So the paper goes on to say our data suggests that VEGF-C could be utilized as a clinically viable biomarker to guide patients with chromophobe kidney cancer towards tyrosine kinase inhibitor therapy. While a major limitation of this study is that our data comes from a single patient, examinations of exceptional responders provide a unique opportunity to generate hypotheses which may prove useful in elucidating key molecular mechanisms behind disease processes. These so-called N of 1 case reports have been previously used to uncover new cancer treatment options, and the nation's leading cancer research centers have been systematically collecting data on exceptional responders to guide future work on targeted therapies and drug discovery. additional studies exploring treatment options for patients with non-clear cell kidney cancer, like me, are needed. In their absence, we would recommend tyrosine kinase inhibitors for patients whose tumors bear a similar molecular profile. Okay, so perhaps the notion that tyrosine kinase inhibitors being ineffective for non-clear cell kidney cancer, or in my case, chromophobe kidney cancer, is not so clear-cut and is perhaps a successful strategy depending on certain biomarkers. In fact, the paper goes on to say, indeed, and this is so important, since variability of clinical outcomes are largely determined by tumor heterogeneity, which is a term that describes the differences between tumors of the same type in different patients, the diverse genomic landscape of chromophobe kidney cancer and non-clear cell kidney cancer in general better lends itself towards precision medicine, which can deliver tailored, targeted therapies exploiting the specific subtype of cancer expressed in a given patient. Okay, so what that means is that we need to investigate each non-clear cell renal tumor for their many different characteristics and which specific genes are mutated and which specific genes are being expressed, as one patient with a particular chromophobe kidney cancer tumor might respond very differently from another one to the very same drug. So as such, we can't make blanket assumptions like my oncologist did that tyrosine kinase inhibitors do not work for chromophobe kidney cancer, because it depends on the very specific nature of the gene expression, of the gene mutation in one chromophobe cancer that's in one particular patient versus another. And so with that said, if this paper is saying, hey, use VEGF, VEGF-C in particular as a guide for whether or not you should give a chromophobe kidney cancer patient TKIs, I guess the question becomes, did my oncologist check whether the VEGF-A, VEGF-B, or VEGF-C protein that their corresponding genes produce or provide instructions to make, did my oncologist check whether any of those proteins were being expressed so that we could say, hey, you actually might benefit from tyrosine kinase inhibitors? No, they did not. They didn't. They didn't look at whether VEGF-A protein, VEGF-B protein, or VEGF-C protein was being expressed. They did check to see if there was if there was a mutation in the VEGFR1 and VEGFR2 receptor, right? Which I didn't have. They did check for that, but they didn't check to see if the proteins that bind to the different receptors like VEGFR1, VEGFR2, and there's also a VEGFR3. They didn't check that. So let's look at VEGF-A first. Let's break this down. The VEGF-A protein is one of the most important regulators of angiogenesis and plays a crucial role in cancer angiogenesis and progression. Recent studies have highlighted a relationship between VEGF-A expression and kidney cancer occurrence. Okay, that's very important. VEGF-A regulates angiogenesis and vascular permeability by activating two receptors, VEGFR1 and VEGFR2. And again, I'll say it again, as mentioned earlier, VEGFR1, by the way, which is coded by the FLT1 gene, and VEGFR2, right, VEGF receptor 2, is coded by the KDR gene. Now, my genetic test did look at those two receptor genes for mutations, and they didn't find any there, but that doesn't mean the VEGF-A protein is not being expressed at a high level in my tumor. In fact, according to a paper entitled System Analysis of VEGF-A in Renal Cell Carcinoma, The expression, prognosis, gene regulation network, and regulation targets, VEGF-A, was upregulated. Sorry, that might be a bit confusing. That's okay. That's the title of the paper. So let me say the title again so that this makes more sense. According to a paper entitled System Analysis of VEGF-A in Renal Cell Carcinoma, the expression, prognosis, gene regulation network, and regulation targets, VEGF-A, so quoting now from the paper, VEGF-A was upregulated in patients with kidney renal clear cell carcinoma and kidney chromophobe cancer, and it was downregulated in patients with kidney renal papillary cell carcinoma, which I do not have. But it was upregulated, meaning the chains were off and the protein was at a higher level than it was in normal renal cell tissue. So VEGF-A can be highly expressed in kidney chromophobe cancer. They also found in this study that the STAT3 protein, the NFKB1 protein, and the HIPK2 protein were significantly regulated factors in patients with chromophobe kidney cancer. So it turns out STAT3 proteins are key transcription factors. Transcription factors, by the way, are proteins that help turn specific genes on or off. And STAT3 proteins are abnormally activated in a variety of malignancies, including kidney cancer. STAT3 inhibition can hinder kidney cell migration. STAT3 inhibition can hinder kidney cancer cell migration and invasion. NFKB1, that protein is related to the pathogenesis of many malignant tumors, including kidney cancer. And the HIPK2 protein plays a unique role in the regulation of cell apoptosis, again, cell suicide, as well as proliferation, or where those cancer cells spread. It's also HIPK2 also plays a unique role in DNA damage repair and other basic processes. Thus, the paper says HIPK2 protein has attracted increasing attention. So my question is, was I tested to see if any of these, first off, was I tested to see if VEGF-A protein, VEGF-B protein, or VEGF-C protein was upregulated in my tumor? No, I was not. Was I tested to see if any of these transcription factors, right, STAT3, NFKB1, HIPK2, was I tested to see if any of those transcription factors that turn genes on or off were expressed in my tumor? No, I was not tested for that either. Furthermore, the paper says the following genes have the strongest correlation with VEGF-A expression in patients with chromophobe kidney cancer: the CKMT2 gene, the RRAGD gene, and the PPARGC1A gene. Were any of these genes tested in me for being mutated in my tumor tissue? No, they were not. Man, they tested for 183 genes typically associated with kidney cancer, or shouldn't say with just kidney cancer, 183 genes that are associated with cancers in general. They tested for 183 of the most popular ones. Did they test for any of the things that I just said? No, they did not. So what they also found, by the way, in this study was that patients with chromophobe kidney cancer and papillary kidney cancer have low VEGF-A expression levels. I'm sorry. That's a mispronunciation on my part. Let me say that again. The paper also found that chromophobe kidney cancer and papillary kidney cancer patients have low VEGF-A expression had longer survival than those that have high VEGF-A expression levels. Man, that is so important to figure out then, right? It is real. You would think, based on this study, it is super important to know that should you have chromophobe kidney cancer or papillary kidney cancer, it would be really important to know if you have low VEGF-A expression levels or high VEGF-A expression levels. Because if you do have high VEGF-A expression levels, it means that you might not survive as long. If you have low, which means you better be even more urgent in your research, in your studies, and in your strategies. It's also super important to know if you have low. How important would it be to know, hey, you have chromophobe kidney cancer or papillary kidney cancer, but you have low VEGF-A expression levels, because that would mean, hey, you have a much better chance of surviving much longer. Again, did they test in my tumor for this? No, they did not. Now, interestingly, in the study involving our chromophobe cancer patient who had the exceptional response to the tyrosine kinase inhibitors, they established actually gene expression levels of VEGF-A, VEGF-B, and VEGF-C for not just his chromophobe kidney cancer tumor, but actually they did it for a range of different kidney cancers so that they can compare his cancer tumor cells to the others. And what they did was they studied 102 clear cell kidney cancer tumors. They studied 14 papillary kidney cancers. They studied 10 chromophobe cancers, 14 oncocytomas, and 12 normal kidneys. Okay. And they found that VEGF-A expression in the exceptional responder was similar to levels seen in the other chromophobe cancer tumors, as well as the normal kidney cancer samples. So that's interesting, right? They pretty much found, hey, the patients and the other chromophobe tumors all exhibited the same type of VEGF-A expression as the normal renal cell tissue. And so that might correlate with, hey, if it's expressed, if this patient's chromophobe kidney cancer tumor is expressing the same type of VEGF-A protein levels as you would find in a normal kidney, then clearly it's not being expressed at super high levels. And so that might very well correlate with what the other paper told us, the system analysis of VEGF-A paper, which surmised that chromophobe kidney cancer patients whose tumors exhibit lower VEGF-A expression survive longer than those with high VEGF-A expression levels. So, hey, maybe that's one of the biomarkers that, really are fleshing out what's happening here with that exceptional responder, right? That chromophobe kidney cancer patient who's doing really well on the tyrosine kinase inhibitor drugs. All right. What about VEGF-B protein? What does the literature tell us about that? Well, in the exceptional responder, although his VEGF-A levels were not high, his tumor did display increased VEGF-B expression. And according to a paper entitled VEGF-B Promotes Cancer Metastasis Through a VEGF-A Independent Mechanism and Serves as a Marker of Poor Prognosis for Cancer Patients, I'm going to quote now, VEGF-B expression is reversely correlated with primary tumor growth, demonstrating that it negatively regulates tumor angiogenesis. What that means is that VEGF-B doesn't play a factor in the growth of an initial tumor that you may get, like that first primary tumor that they find. Instead, the paper says that VEGF-B markedly promotes cancer metastasis, right? The spread of that cancer through the remodeling of the tumor microvasculature. As such, targeting VEGF-B may be an important approach for the treatment of cancer invasion and metastasis. Okay, so that's super important to know, right? Like if you have high VEGF-B levels, it might mean that, hey, okay, well, that is a biomarker that tells us that if you have that, well, it might mean your cancer is has the propensity for invasion and metastasis, right? It has the propensity to advance, especially if they're finding second and third tumors or areas of invasion outside of the local area or even in the local area. If you're having VEGF-B expressed at a higher level, that's important to know, right? Again, that's how you do super targeted prioritization, right? That's how you tailor a response to a particular type of cancer. Why wasn't that done in my case, right? And I wouldn't even know this, by the way, if I didn't do the damn research. All right. So that's the VEGF-B protein. And then there's VEGF-C, the VEGF-C protein, which in our exceptional responder was also significantly elevated when compared to the other 10 chromophobe tumor samples, as well as when compared to the normal renal tissue. Now, according to the papers, so I found two papers, expression of vascular endothelial growth factor C, so expression of VEGF-C in renal cell carcinoma. According to that paper, and according to another paper, VEGF-C and its receptor, VEGF-R signaling in angiogenesis, I'm going to quote now, VEGF-C is highly expressed in cancer tissues of kidney cancer patients and is related to clinical stage, pathological differentiation, and lymph node metastasis, as this protein develops a higher affinity for VEGFR3. Remember I said there's another VEGF receptor protein. There's VEGFR1 and VEGFR2, but there's also VEGFR3. And this VEGF-C protein develops a higher affinity to bind to that VEGFR3 receptor, which is expressed on lymphatic endothelial cells and stimulates the receptor for lymph angiogenesis. And we know that in the exceptional responder that the chromophobe kidney cancer had indeed metastasized and spread to his lymph nodes. So given all of this information, man, why not look into VEGF expression in my tumor? Again, this is most likely because on the whole, my oncologist is probably surmising that, well, the literature says that TKIs, tyrosine kinase inhibitors, are not effective in chromophobe kidney cancer. However, we know from the research paper on the exceptional responder study that, and again, right, I'm quoting here, since variability of clinical outcomes are largely determined by tumor differentiation, the diverse genomic landscape of chromophobe kidney cancer and non-clear cell kidney cancer in general better lends itself towards precision medicine, which can deliver tailored, targeted therapies exploiting the specific subtype of cancer expressed in a given patient. So look, that type of approach wasn't done with me by my oncologist. So you know that I'm definitely going to be discussing these papers and these studies and this research with my oncologist when I see them again next month. And I'm going to discuss this whole idea of identifying whether or not I have high levels of VEGF-A protein, VEGF-B protein, VEGF-C protein, as this could absolutely serve as a guide to possible targeted and tailored strategies should I need it or want to take that route in the future. But the fact that I have to ask for this type of analysis, the mere fact that I had to find this information out on my own, opens the door to a whole bunch of questions regarding my quote-unquote expert oncologist's approach, as well as my confidence in their knowledge and capabilities. There was no recognition or mention by my oncologist of the rarity of having both the c-KIT protein expression along with the KIT mutation in my tumor tissue, and how this might be a factor in tyrosine kinase inhibitors possibly being more effective. And why not test for VEGF? VEGF-A, VEGF-B, VEGF-C. Look, if you're going to test for 183 gene mutations, why not look into this as well? Why make the assumption that it's not relevant given the findings of these other papers? I mean, is my oncologist even aware of these studies? What else is my oncologist and or any oncologist for that matter either unaware of, not paying attention to, or given they operate within a very structured healthcare system that follows a cookie cutter standard of care prescribed approach to cancer, perhaps it's unrealistic for me to expect them to turn every cancer patient into a science project. Maybe they don't have the time, the will, or the motivation. And by the way, this is what we're going to get into next time on the next few episodes. We'll talk about the realities of being an oncologist and why most don't or simply can't devote their time into turning every patient into a forensic investigation such that they actually take the time to truly figure out your individual cancer puzzle. And we'll also delve far deeper into the rest of my research, which ultimately unearthed what is possibly the most important and profound advance in targeted drug therapy for chromophobe kidney cancer to date, along with a number of other cancers as well. So, okay, with that, we're going to end this episode. Remember, question everything, people. When it comes to your particular health condition, take nothing at face value. Get second and third opinions to validate what you are told by matching up what one expert says versus what another proclaims. Do your own research, because no one will ever care more about fixing you than you.